All right, moving on to 9.1, exploring the sine law. At the bottom of the page, it shows you the sine law, which is this formula, and that's also on your sheet at the back, your formula sheet. So first thing we have to do is know what a triangle is, what it looks like, and all the parts to it. Record the angles in XYZ from least to greatest. So if this is the smallest side, that means that this angle is the smallest, and it says least to greatest. So angle Y is the smallest, then this side is second, so that would be angle Z or Z. And then last would be X, because it's the biggest opening. Okay, Janelle is a commercial artist in Fort Mac. 2 of her triangular logo designs are shown below. What is the relationship between the sides and the angles that are opposite the sides? So we're gonna set up the ratio, all 3. First one, little a. When you look at a triangle, you find the big A. Little a is just opposite of that. You find big B, little b is opposite of that. Big C, little c is opposite to that. Then you can fill in everything. So little a is 7.11. Little b, 6.25 over 60. And little c, 4.64 over 40. So I'll show you how to do this on your calculator. So you take 7.11 and you divide by sine of 80. And you get 7.2. Now you do it for this one, and you're gonna notice that you're gonna get the same answer, 7.2. And you guessed it, for the third one, you're gonna get 7.2. So this is a ratio. Compare the ratios in question 1. What do you notice? The ratios are the same. Use PQR. What is the value of each ratio? Okay, well, let's break down. Little p is here, 6.3 to 67. Q, little q, 5.6 to 55. And little r, 5.8 to 58. And let's do one on the calculator. You get 6.8. And if you pump out the rest on your calculator, they're all gonna be 6.8. They're identical. Compare the ratios, what do you notice? They're the same, again. And that's why you can use sine law to figure out the other ones that you don't get in questions. And I'm sure we're gonna get into that right away. All right, example 1. We have Logan builds this custom table. And their dimensions are to the right here. So what are the known values? Well, we have big A, we have little a, we have big B. We don't have little b, but that's what we're gonna be looking for. We have big C and we have little c, all in here. Hint, use the given measurements to determine the precision for answers. Okay, how do you use the sine law to calculate the length? Well, we're gonna use what we are given. We have big B, we're looking for little b. We have little c, and we have big C. So plump them in. Sine of B, sine of 60. Little c is 85, and sine 70. So we want to isolate this little guy. That means get him by himself. To do that, we have to get rid of sine 60. So what they did is they times both sides of the equal sign by sine 60. When you do that, these two cancel. You're just left with b, and then you have sine 60 times 85 over 70, which is what we're just bringing down. So if you pump that in your calculator, if you do it right, I'll show you how to do it the first way. And remember, you want to do this along with me because you will be doing the provincial exam after you finish all of these booklets. So we have sine 60. So type in sine 60 times, then we're gonna bracket, because they have a bracket down here, bracket 85 divided by sine 70. And make sure you close the brackets, equals 78. The third side is 78 centimeters. And does that make sense? Well, these are 85, 70, or yeah, 69, 78. Makes sense. That's how you do the sine law. Let's do another one. So we have 18 feet here, 15 feet here, 22 feet there. Then our angle is 55 degrees here. Okay. Elena is building a triangular deck in Prince Rupert. At what angle to the garage should Elena place the beam for AC? So AC, what is the angle? We're looking for angle A then. At what angle A should the beam be? So we're gonna use the formula. When you're looking for an angle, you wanna pick, here I'll show you the options here. When you're looking for an angle, you want to use this side. When you're looking for a side of a triangle, you want to use these. Angles, sides. So, what is angle A? To do this, you type in little a, which is 15, over sine B, which is 55, over B, little b is 18. We have to isolate sine A, so what we're gonna do is times both sides by 15. Those cancel. Times by 15. That way this is 15 here. Sine 55 over 18. Now, how do we do that in a calculator? I'll show you once so you know. 15 times, put the bracket in like they have in the question, sine of 55 divided by 18, close the bracket. Sine of 55 divided by 18, close the bracket. Boom. Equals, oh, a huge decimal, 0.68. So, we know the decimal of the angle, but that's no good to us. Let's convert that to a degree, because I don't care about decimals, I care about degrees. To do that, you just have to, on your calculator, every calculator has the inverse sign, which is represented as a sine -1. There's also inverse cos and inverse tan that you might have to use. But we're dealing with sine right now. So inverse sine, to get to that, you have to click the blue second function button, which opens up all the blue now, all the light blue stuff. And you click sine. And some calculators just show sine inverse, which is -1. And then you put 0.68 equals 43 degrees. Does that make sense? We're looking at the angle 43 and it's 15, 55, 18. Yeah, it makes sense. So we got that one. Excellent. So moving on to practice. What is the value of each ratio to 1 decimal? Again, we have this, plug everything in, and your ratios should be all the same. So that's you. Just like the examples we did. Number 2, let's see, calculate each side length. And 3, calculate each measure length. So I'm gonna do G, and I'm gonna do 3A. Those are the 2 that I will do. So 2A and 3A, everything else is you guys. All right, so big G, little g over big G is 80. Then we are using big T, which is 40, and little t, which is 24. Plug that into my calculator. Have to isolate the G by itself, so sine 80 goes onto the other side, 24 over 40. Plug it into my calculator, I get 36.7, so about 37 centimeters. Does that make sense for G? 37? Yes, it does. So do the exact same thing on this side for little z, which is right here. That's D. So you're using sine big Z. Then we have to use D, little d over sine of the big D. 3a, calculate each angle measure. So F. So see how it switched from the little stuff to now the big F's are on the top because we're looking for angles. Sine F over little f, which is 15.9, equals sine of the angle that we're given, which is J, over little j, which is 14.8. Pop that to the other side to isolate. 15.9 sine of 65 over 14.8. And we get a decimal of 0.97. Inverse sine it so that we get 76.8 or 77 degrees. So you guys do the rest of those and let me know how it goes. All right, number 4. We have determine the length of each side C for the triangle at the point with each method. So we're going to use our old sine ratio and we're going to use sine law. Sine equals opposite over hypotenuse. Opposite over hypotenuse. We're looking for hypotenuse. So rearrange. Hypotenuse equals opposite over sine A. Opposite is 5 feet over sine of 30. That equals 10. Now let's see if we get the same answer here. Little c over sine C is 90 degrees equals little a, which is 5 over sine 30. Isolate for C. Sine of 90 times 5 divided by sine 30. What does it equal? You're going to find out it equals 10 feet. Why do both methods in part A have the same result? Well, we know since sine of 90 degrees equals 1, we know that sine 90 times 5 over sine 30 is just 1 times 5 over 30, which is the same as 5 over 30. So that's why they both equal 10. Is the sine law true for right angles? We just proved that it is. It works for right angles. So you never have to do sine ratio if you don't want to. But I mean, they're both handy. All right, 5. Jace creates a mosaic using ceramic tiles. He needs to cut a tile as shown to the right. What are the measure of angle C? Okay, I'll give you the formula and you guys got to do it. So sine C over little c equals sine A over little a. Sine A is hard to read. It's 64. You have everything else. You should be able to fill it in and solve. And remember, when you get the decimal, sine inverse the 0 point whatever to get your answer in a degree. Okay, so that was you. And then we have 6. Amy's a city planner in Victoria. She plans new roads. Show how Amy can use the sine law to calculate the length of the new road in the diagram to the right. What information does Amy need? If Amy knows angle O and angle R and the length of Oak Street, she can use the sine law to figure out the length of the new road from Oak Street to Elm Street. Oak over sine O equals new road over sine R. That's all you gotta know. So next video is going to be moving on to 9.2.